Okay, so in this video I'm going to show you how you can use this floodable length curve from the blue pages, okay, the floodable length table. So before we continue, let's just talk about a few things. So this is a watertight bulkhead. These vertical lines are all watertight bulkheads, okay? For this ship, this is hold 1, this is hold 2, this is hold 3, this is the engine room, this is hold 4, this is hold 5. This line here is a 45% permeability, okay? And what this is showing you is that, you know, if in this hold you had 45% permeability cargo, if you flooded this hold, okay, you would use this this line here and this line here, they're given you by the architect. You would see that, that the intersection of those two lines is below 45% permeability. So if I had 45% permeability and I flooded this space, my ship would survive. If I had 45% permeability in this hold and I flooded hold 2, okay, because the intersection of these two lines is below the 45% curve, I would survive. I would survive here, I would survive here, here, and here, okay? So this ship can certainly survive one compartment. The question is, could this ship survive two compartments? Well, to do that, what I'm going to do is, let's say let's take a look at this, okay? Here's a question for you. Use the floodable length curve, that's that, okay, from the blue pages of the stability reference book. If the curve represents 45% permeability, that's this curve, okay? And we're going to flood holds 2 and 3, okay? All right, so that's this hold and this hold, okay? The vessel will sink if the permeability exceeds what percent, okay? So right now, if I flood this hold alone, I'm not going to sink if I have 45% permeability. If I flood this hold, I'm not going to sink. But what happens if I flood both holds? Well, here's what I'm going to do. I'm going to take this line given to me by the architect, and I'm going to draw that up from the forward leg of the forward hold. And then I'm going to choose the after leg of the after hold. So this works for holds that are next to each other, okay? So I'm going to follow this line up, okay? Now that's the intersection, okay? That's essentially where I'm going to hit the margin line or where I'm going to sink, okay, depending on a few little assumptions there. So what it turns out here is that if I was to flood hold 2 and hold 3, and my permeability was 45%, this vessel would sink past the margin line. Matter of fact, this vessel would sink altogether, okay? So now the question becomes, what permeability is that, okay? So it's going to be something less than 45. So if my permeability was something in the 30s in these holds instead of 45, I'd probably be able to survive. So what I want to do is I want to figure that out now. So what I'm going to do is I'm going to create a proportion for that, okay? Here's what I'm going to do. First thing I'm going to do is I'm going to put my pencil down at my intersection point, and I'm going to use my triangle, all right? And I'm going to draw a line straight down from that intersection point down to the keel, okay? And great. So now I'm going to need a formula. So here's the formula that I'm going to use, okay? The length, okay, of the original, okay, over the permeability new equals the length new over the permeability old. Okay, so I'm going to explain what all that stuff is now in just a sec, okay? So before we do this, though, we're going to need some little tool to measure with, okay? So I got two different triangles here, all right? This triangle is set up for a chart of 1 to 80,000 scale, okay? These are not inches. These are not millimeters, centimeters, okay? This is a 1 to 80. This triangle is in centimeters and millimeters, okay? So I'm going to use that one because, I'm more comfortable with that, okay? So now, this is what I'm going to do. This is the original permeability. So if I'm using that, okay, permeability old, 45 is going to go there. And what am I looking for? I'm looking for the new permeability, okay? That's going to be represented by X, okay? So permeability old is going to be 45 for each of these problems that we give you, all right? And the permeability new is going to be what we're looking for. All right, and remember we're doing problem 1 here, okay, which is hole 2 and 3. So I drew my line up from the forward edge of 2, the aft edge of 3, okay, and that's my intersection. So now what I'm going to do is I'm going to start to measure distances. So this is the floodable length original for 45%. So I'm going to measure that distance, okay? So I'm going to put my triangle, I'm going to put the 0 of my triangle right at there, right at that spot, okay? And then I'm going to come down here, and it looks to me, I'm going to measure all the way down to the baseline, okay? You could use any one of these lines, okay, but the baseline is going to be the most accurate, okay, for a couple of reasons. One is because it's straight. This looks like the deck is curved here a little bit. And the other reason is because it's a longer distance all the way down to the baseline, so any error will be averaged over a little bit greater distance. So that to me looks like that is about 5.8 millimeters. So the original is 5.8 millimeters, okay? Now, what is the new length? Well, this is the new length. So I'm going to measure from 0 down to the baseline now for this. And that to me looks like it's 7 millimeters, maybe 7.1, 7 millimeters even, okay? So now what I'm going to do is you can arrange this any way you want. I'm just going to flip everything over, okay? X over 5.8 equals 45 over 70. Now I'm going to multiply both sides by 5.8, cancel that out, okay? And let's check what we got here. So 45 times 5.8 divided by 70 is, so 45 times 5.8 divided by 7 is 37. Okay, so this is 37% permeability. If these two holes were at 37% permeability cargo, okay, I would be right at the edge of flooding, okay? So anyway, that's how you use this table.